Hello everyone, I want to talk to you about the derivative of e dx. It is one of those rare functions that if you start off with e dx, it is its own derivative. I can only think of one other function that does this. So please keep in mind, start off with e dx, it's like putting it on a copy machine or a duplicator, and you end up with what you started off with. So when you go over here, you'll notice that if I start off with e to g of x, notice not just x, but e to some function, then its derivative is, there's your copy, right? So you're still abiding by the rule that e dx is its own derivative. But since this is a chain rule, you'll notice the very last step is this power that you started off with. You have to clean that up. That was your brick. You want to disintegrate the brick, which is why you're multiplying by the derivative of the brick. Okay, so you'll notice what I put right here is I said cop e, to remind myself that the very first step for the exponential function is just to copy it down. It shouldn't change. It should be a duplicate of what I started off with. And then the last thing that I do for this two-step process is to take the derivative of the power. All right, so I'm going to do the problems that are on page 3 of your notes, and I'll just go through. Okay, so for number 1, it says f of x equals e to the 4x squared minus 6x. So let me separate this so that we can. Alright, so then in order to take the derivative, notice I've got this e, so I should have a duplicate of what I started off with. And I'm going to do exactly that. So copy it down, e to the 4x squared minus 6x. Don't change that. Okay, that'll take care of the e part. Check. But I didn't do anything with the power. So I had to go back and clean that up. And it's always going to be multiplied, just like with the chain power rule, by the derivative of the brick. The brick has to disintegrate. So the derivative of 4x squared minus 6x is 8x minus 6, like that. Okay, so oftentimes I put the 8x minus 6 in the front. It's a matter of preference. Okay, so number 2 reads that f of x equals 3 times e to the 7x cubed. All right, so here we go. F prime of x then equals 3. Pull that out so I can focus just on this part that has the e. So here's your two-step process. It's got an e in it, so I'm going to go back up here. Notice cop e. It should be an exact duplicate of what I started off with. E to the 7x cubed. So check, dealt with the e part. Now I have to deal with this power that I didn't touch. So then we multiply by the derivative of this power, which is 21x squared. All right. So let's see, in this case we can actually combine some things. The 3 is raised to the first power. The e is raised to the 7x cubed, so I won't be able to combine that. But the 21x squared as a chunk is raised to the first power. So I can combine this with this. So then f prime of x equals 63x squared e to the 7x cubed. And I'm done. Okay, as I mentioned, I typically write things in the front of my exponential function. All right, let's try a third one. So the third one reads f of x equals 10 e to the 5 minus x. So then the derivative, f prime of x equals, pull the 10 out so that you can focus on the part that has the e on. Now the e rule is to cop e. So e to the 5 minus x. That deals with the e part. But now I got this power that I didn't do anything with. That's your brick, right? You got to disintegrate the brick by multiplying by the derivative of the power. Derivative of 5 is 0. And then the derivative of negative x is negative 1. So then f prime of x equals Add the 10 is to the 1, the negative 1 is to the 1. Negative 10 e to the 5 minus x. Like that. Okay, let's keep going. And the fourth one reads as such. F of x equals 5 over e to the 8x. Alright, so it would be helpful for us to have the exponentials in this form right here. Okay, so you should have e as a base and something to the power. However, you want to make sure that you don't have any negative powers there. I'm sorry, it's okay to have negative powers, you just don't want anything in the denominator. So I'm going to rewrite this as 5e to the negative 8x. So then when I take the derivative, all I've done is just shift that up. 5 comes out, copy e to the negative 8x times the derivative of this power. Again, when I copied it down, I dealt with the e part. Now I got to disintegrate that brick by multiplying by negative 8. So then f prime of x then equals negative 40 e to the negative 8x. Of course, you could take that one step further. This can go to the denominator because of that negative power. So negative 40 over e to the 8x. That should do it. Alright, so you guys have one more problem that I'm going to do. And that is that g of x equals 6x plus e to the 4x cubed raised to the 5th power. Now the reason that I gave you guys this one is because I want you to see that your other rules could be involved in a derivative involving e. So then your derivative or your slope generating machine, your instantaneous rate of change. Okay, if I were to read this out loud, it would say take 6x plus e to the 4x cubed times 6x plus e to the 4x cubed times 6x plus e to the 4x cubed. You do that 5 times, right? So the 5 is the thing that's driving this, so I have to deal with the chain rule before I do anything else. Bring the 5 down, 1 less power. Okay, now if you remember what we said with the chain rule, this is a derivative. 1 down, the power down, 1 less, which means that you have to leave the inside alone. These have to be exactly the same, right? Times the derivative of the inside. So now we're getting to disintegrate the inside. So the plus should be considered as a wall. That's what I typically do. It allows me to take the derivative of what's on the left and then add that to the derivative of what's on the right. Anytime you have a sum or a difference, that's how that works. So the derivative of 6x is just 6 plus. Now I'm going to take the derivative of this e, which is copy e to the 4x cubed, times the derivative of this power here, which is 12x squared. So I can close off that bracket. Technically, there would be 2 sets of brackets if you started the bracket there. All right. So let's see. G prime of x then equals 5. Technically, you could multiply it by 6 plus 12x squared e to the 4x cubed, and then that could be multiplied by 6x plus e to the 4x cubed, all that to the 4th power. Now, if you so desire, you can of course combine those two, in which case g prime of x would equal 30 plus 60 x squared e to the 4x cubed times 6x plus e to the 4x cubed to the 4th power. Alright, so make sure you check that. Make sure that there's no mistakes. But that generally is how you would take the derivative of these various exponential functions.